Imagine for a moment that the very fabric of our universe is governed not just by the familiar laws of physics, but by a deeper principle, the economy of memory. Picture a hidden logic embedded beneath space and time, where patterns repeat themselves not because of random chance, but because somewhere, somehow, a conscious choice has been made to store the rules of reality in the most elegant, cost-effective way possible. Instead of cataloging billions of chaotic exceptions, the universe prefers to remember simple, beautiful laws. What if this drive for efficiency is more than a mathematical curiosity? What if it's the first clue that we are living inside a simulation? At first glance, the notion that the universe compresses information sounds like the marketing pitch for a new kind of computer chip. But modern physics has been steadily revealing that information is as real and fundamental as mass or energy. Think about the laws of physics themselves. They're not endless lists of every possible outcome, but concise routines, equations, and principles that, when applied, can generate limitless complexity from a handful of basic instructions. This is compression in its purest form, and it's dazzlingly efficient. Physicist Melvin Vopson takes this idea a step further. He suggests that the universe's tendency to minimize information isn't just a happy accident or a side effect of mathematics. It's a sign of deliberate optimization. In other words, the cosmos itself could be organized to save on storage and processing power, much like a sophisticated piece of software. If you've ever played a video game set in a vast open world, you've witnessed procedural generation in action. The game uses simple algorithms to create mountains, forests, and cities on the fly, requiring only a fraction of the data that would be needed to design every detail manually. Nature, too, seems to favor rules that can be reused and recombined to create immense diversity. Could this be an echo of the same computational strategy? Of course, there's a crucial difference. In games, we know exactly who did the programming. In the universe, the identity of any programmer is, at best, a philosophical question. Patterns alone don't prove the existence of a designer, but they're certainly compatible with the idea of intentional design. The physics of information is now a legitimate field, thanks to thinkers like Claude Shannon and John Wheeler. These pioneers argued that information might be the true bedrock of reality. Vopson builds on their work, nudging the conversation into speculative territory. What if the compressibility of physical laws is a sign that our universe is being run like a giant optimized simulation? For this hypothesis to have scientific merit, it needs to generate predictions we can test. Might we find physical limits to complexity? Places where reality refuses to become more intricate because the memory budget is exhausted? Or perhaps we could discover discrete signatures in the underlying mesh of space-time, clues that the universe is built atop a computational grid. Some researchers have already begun searching for such anomalies, probing for irregularities in physical measurements that might betray the presence of a hidden lattice. So far, results are inconclusive. The challenge is formidable. If a simulator exists, it could theoretically tweak its code to cover up any evidence of its handiwork, making the hypothesis almost impossible to disprove. Despite these obstacles, there's intellectual value in exploring just how compressible the universe truly is. How much of what we observe can be reconstructed from simple informational patterns? If we reach a point where certain phenomena stubbornly resist compression, where we encounter informational artifacts that defy reduction, then we might have grounds to challenge the idea that everything is about data economy. On the other hand, if nature continues to yield to computational regularities, that would be a significant data point for philosophies that treat the universe as an algorithm. As audiences, we're drawn to evocative analogies. Imagine if reality only renders details when they're observed, like a video game saving resources by loading graphics on demand. It's a powerful and slightly unsettling image. But does any of this change the way we live our daily lives? In practical terms, probably not. The laws of physics remain robust, regardless of their origin. Yet the cultural implications could be profound, shifting our understanding of agency, purpose, and the very nature of existence. There are pitfalls here, too. If we allow speculative metaphors to ossify into dogma, we risk stifling rigorous empirical investigation. It's important to distinguish between metaphor and operational theory. The responsible scientific approach is to propose concrete experiments, searching for discrete signals in cosmic radiation, unexplained limits on entropy, or statistical regularities in biological processes that defy evolutionary expectations. Philosophically, the simulation hypothesis reactivates timeless debates: determinism versus free will, creation versus creator, appearance versus reality. These questions echo through history, from ancient philosophy to contemporary pop culture. Popular media has already seized upon these themes. Think of The Matrix or Black Mirror, crafting rich, speculative worlds around the notion of simulated reality. But the version debated in academia requires caution. Fascinating ideas that cannot be verified risk drifting into pseudoscience. Let's add a twist. Perhaps the simulation is not a technological experiment, but an ethical architecture, a laboratory where moral and social scenarios are played out, informing decisions in some deeper base reality. This reframes the idea not as technological manipulation, but as a kind of spiritual or philosophical test. What if, instead of an anonymous programmer, we imagine a divine creator? Many religious traditions describe a transcendental agent possessing foreknowledge and purpose, traits that, metaphorically, align with the role of a simulation controller. Take the Bible, for example. Its narratives often resonate with the theme of foresight, prophets foretelling future events, central figures such as Jesus speaking with apparent knowledge of their destiny. These passages can be reinterpreted as cultural expressions of humanity's intuition that reality might be orchestrated in ways we cannot fully comprehend. Yet, caution is essential. Using sacred texts as scientific evidence is a leap of interpretation. Prophecies and religious predictions serve theological, literary, and communal roles. To use them as empirical proof requires rigorous criteria that science demands, criteria that ancient texts were never designed to meet. This tension between science and religion, between empirical rigor and metaphoric resonance, is at the heart of the simulation debate. It challenges us to think deeply about what counts as evidence, what counts as explanation, and what counts as meaning. If we pursue this line of thought, we must be vigilant, always separating the poetic from the operational, the suggestive from the demonstrable. The simulation hypothesis, as currently framed, is an invitation to curiosity, to skepticism, and to humility in the face of mystery. Perhaps the true value in these musings lies not in proving or disproving a simulation, but in expanding our sense of the possible. By questioning the compressibility of the universe, by probing the regularities and the anomalies, we train ourselves to look more closely at the world and at our place within it. Maybe, in the end, the universe's economy of memory is less a secret code and more a reflection of a deeper logic, a logic that invites us to wonder, to explore, and to imagine. The journey from physics to philosophy to theology is not a straight path, but a winding road full of surprising vistas. Whether or not we live in a simulation, the questions raised by this hypothesis ask us to reconsider what it means to be real, what it means to know, and what it means to matter. It's a conversation that is far from over. Every new experiment, every philosophical insight, every cultural story adds another layer to our understanding. And while the final answer may remain elusive, the journey itself, driven by curiosity, skepticism, and wonder, is worth every step. So, as we reflect on the possibility that our universe is optimized for memory, compressed into patterns and laws, let's remember that the search for truth is itself a pattern, repeated through generations, compressed into stories, and rendered on demand in the unfolding adventure of human thought.